What up, what up? Today in AP Precalculus land, we're going to talk about sections 2.9 to 2.12. Lots of logs. It's like we're talking about maybe building a tree in a cabin, a log cabin. I blew it. Exponential stuff too. Let's talk about the logarithmic rules. There's a bunch of them that we have to know. So if I give you something like, I don't know, log base b of y equals x. This is the most basic log rule. We could write this out as b to the x equals y. Okay, this is how you shift from logarithmic form to exponential form. So if I give you a problem, there's two types of problems that you could see as far as basic types of problems. If I give you a problem that says log base 2 of 8 equals 3, and I'm like, please rewrite that into exponential form. What I do is I would say, all right, well, you would be my b, and you would be my y, and you would be my x, and so I'll write that out as b to the x, 2 to the third, equals y, which is my 8. That's way number one of doing a problem like this. Way number two is I give you exponential form. So something like 10 to the x equals 519. Okay, now this is a calculator type of problem, but you get the idea. We would write that out as, well, let's call you b, and let's call you x, and let's call you y. We would write that out as log base 10 of 519 equals x. Then we would use our calculator to solve that. And you might be thinking, how would we use our calculator to solve that? That's gross. Log base 10 is the same as log. Same exact thing. So the regular looking log in your calculator is also known as log base 10. Now this is the primary log rule, okay, that we have. This is you switching from exponential to logarithmic and vice versa. There's other log rules that we need to know and be aware of. Log rule number one, if I have the same base, so log base b of m plus log base b of n, if I have the same exact base for a log and I'm adding logs, multiply the insides. Okay, so log base b of mn. Okay, similarly, rule number two is if I were to use the same exact guy but subtract, common sense would tell us that, well, adding logs of the same base was multiplying the insides, so maybe subtracting logs of the same base is dividing the insides. So log base 10 of m over n. Rule number three is if I were to throw like a coefficient in front of a log. So log base b of m, and there's an a living in front. You can write that out as log base b of m to the a power. Okay, so these are our main log rules. So we're going to have to do, when we solve these guys, we're going to have to do a lot of combining, maybe expanding, maybe doing some other stuff, but you'll see. That's kind of the point of these videos. Okay, don't want to bury the lead. Now, graphing a logarithmic function is weird. All right, so this is how I handle this. Logarithmic functions traditionally look like this. Okay, so something like that. You start from down here, you end up here. Traditionally, logs can't have negative inputs. In fact, they definitely can't have negative inputs. There's no such thing. Now, this is what I would do. Okay, let's say I ask you to graph something like y equals log base 3 of x. Okay. If you go to your calculator and you look for log base 3, you're not going to find it. Now, if you're allowed to use your calculator, there's something that you could use called the change of base formula, which is probably something I should have put in the last slide. I totally forgot. I'll go back. But you can't just type that straight in your calculator. You can't go to y equals and type that straight in your calculator. Also, what if you're not allowed to use your calculator? This is what I would do. Okay? I would rewrite this as, sorry. multitasking. I would rewrite this as what we saw in the previous slide, as x equals 3 to the y power. Now, if this was something like y equals 3 to the x power, you would be like, oh, all right, well, let's just pick a bunch of x values and get a bunch of y values and we're done. But it's backwards. Well, this is what I'll do then. I'll handle it backwards. Instead of picking a bunch of x values to try to get a y, I'm going to pick a bunch of y values to try to get an x. So I'll let y equal -2 and -1, 0, 1, 2, 3. And then what I'll do is I'll plug in that y, get an x value, and then when I graph as normal. Okay, so I'm going to select -2, so 3 to the -2 is the same as 1 over 3 squared. So my x value is 1/9, and that gets me -2. If I do -1, that's 3 to the -1, which is the same as 1 over 3. Don't need to do any math there. If I plug in 0 for y, I get x equals 3 to the 0, which is 1, so my x value is 1. If I plug in 1, I get x equals 3 to the first, which is just 3. If I plug in 2, I get x equals 3 squared, which is 9. And if I plug in 3, I get x equals 3 cubed, which is 27. Kind of a big number, so I'm not going to really deal with that. I chose y values like this. Maybe I should shorten that up a little bit. No negative x values, never negative x values. You're not allowed to have a negative domain for logs. It's just a rule. And I have to make sure I go out to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's add 10 for good measure. And let's graph these points. Okay. When x is 1/9, which is almost 0, I get -2. When x is 1/3, I get -1, so something like that. When x is 1, I get 0, so something like that. When x is 3, I get 1, so something like that. When x is 9, I get 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, of course, I'm not going to graph 27/3. But the picture that we get here is exactly like what I said we'd get. What we get is this curve that will never hit the y-axis. Ignore my terrible drawing. Oh, my gosh. Can I scooch this down to make it better? Oh, no, not perfect at all. Let's try it one more time. Let's try it one more time. I'm so bad at these. All right. So let's just sketch it this way. Sketch it like sketchers. Try to flatten it out. Oh, man. Perfect. Look at that. So you'll never have a negative x value because you're not allowed to. You're not allowed to have negative x values. You're not allowed to have negative x values. So by the way, this has to do with a lot of inverse stuff, which we will probably see. You know, if you were to try to remember what a exponential function looks like, it looks something like this. So this is just the y equals x mirror image of it. Now, one of the things that I didn't write on the last page, if you did have a calculator and you were allowed to use a calculator, you could use the change of base formula. Now, the change of base formula says if you have log base b of m, you can write this out as any log you want, but I'll just use regular log for log base 10. Log base 10 of m over log base b. So if you had a graphing calculator and you were allowed to use the graphing calculator to graph that, you would run to the y equals thing and type out, maybe use parentheses because I'm paranoid, log of x divided by log of 3. And that'll do it for you. It'll look like that, just without gross looking lines, because that's what I do, unfortunately. Gross looking lines. Oh yeah, E. What is E? E is a number, 2.718, blah, 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 blah. The natural log, ln of x, is the exact same thing as log base e of x. So it's important to understand that ln follows the same exact rules as log. So if I were to just give you some random problem like this, ln of 3 plus 2 ln of x minus ln of 4y. And if I was like simplify that, you would say, oh, well, ln's follow the same exact rules as logs. So I would have you guys add, which means first let's move you here. So this becomes ln of 3 plus ln of x squared. Now we can combine those through multiplication. So you become ln of 3x squared. And then we have this minus ln of 4y that's just hanging out there. Since you're subtracting them, why don't I divide the insides? Yeah, just like that. When I move, you move just like that. Nicki Minaj. Just kidding, it's Ludacris. Inverse functions of logs. I brought this up accidentally. But, if I were to give you that log base 3 of x, y equals that, right? We know what that looks like. As gross as it looks, we know it's going to look something like this, okay? It's going to look something like that. When you have an inverse, okay, and I ask you to find the inverse of this guy, the way you find an inverse of anything is you first swap the x and the y. So x equals log base 3 of y. Now, you might be thinking, I have to solve for y, but y now lives on the inside of this log. How do I do that? In order to make a log base whatever disappear, you take the base to the of both sides. Now, I know that sounds weird, but there's another rule that says 3, let's not use 3, let's use b. I'm going to use 3 in this case, but let's just have a general rule. B to the log base b of x cancels these guys out and leaves you with just x. Similarly, log base b of b to the x, can't spin that, b to the x cancels out the b's yet again. So if I want to get rid of the log and I want to get y all by itself, what I would do is I would take 3 to the of both sides. Sloppy? Yes. Legal? Yes. 3 to the of both sides cancels that guy out and leaves me with 3 to the x equals y. Flip-flop to make it look better and make that the inverse. And then what we have is an exponential function. And I know exponential functions look like this. And if you're wondering, oh, wait a minute, I know that is a reflection over the y equals x axis. That is a reflection over the y equals x axis. Oh, a phrase that's very difficult for me to say, but I did it. All right. Let's do some problems, shall we? All right, I needed a location change. They're mowing the lawn and blowing leaves outside my room, and it's just too much noise. I can't handle it. So here we are. No calculator. Don't need one. First things first, rewrite 5 to the second power equals 25 as a logarithm. All right, well, the rule was log base b of y equals x can be rewritten as b to the x equals y. So you would be my b, you would be my x, and you would be my y. And now I'm going from right to left and saying log base 5 of x, which was 25, equals 2. Not bad. Not bad at all. All right. I'm going to do the same thing here. Or am I? Now I'm going to do the same thing here. I'm going to rewrite that as that. So you would be like my b, and you would be like my x, and you would be like my y. And so I'm going to write this as 5 to the 3x plus 4 equals 0.04, which is the same as 1 over 25. I mislabeled these, by the way. Meow, 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 meow. No one will ever know the difference. All right, so now that I have that, you might be looking at this and saying, well, how in the world, sir, are you going to do this? I can rewrite 1 over 25 to have a base of 5. Remember, there's a rule that says if you have something that looks like this, just set them equal to each other, and x is going to equal 3. Well, I'm not going to have x is equal to 3, but if I can write this out as 1 over 25, if I can write that out as 1 over 5 squared, right, and then move that up and make that a negative exponent, I have that. Now I have the same exact base for both of them, and I can set the exponents equal to each other like so. So I have 3x plus 4 equals negative 2. Subtract 4, cross u out. 3x equals negative 6. Divide by 3, cross u out. X equals negative 2. X equals negative 2. Now, what I'm going to do for C, I could have done for B, and there would have been no problem with it. So what I'm going to do here is I'm going to say, look, I can rewrite this as an exponent, but one of the things that the guy said in the previous slide is if I take x to the of both sides, it makes the x's go away. So now I have, was I crazy for doing this problem? No, I'm not. I am crazy. Holy cow. Now I have that crosses out. I have 2 equals x to the 16th. I think when I originally made this problem, I wanted something else to happen. And so that didn't work out that way at all. But now what I'm going to do is I'm going to take the 16th root of both sides. But still, something happens here that needs to happen. Again, I wanted that to be x squared. I just miswrote it, but that's all right. When you take the xth root or the 16th root or an even root, you have a plus or minus thing going on. Okay, so you're going to have x equals the positive or negative 16th root of 2, whatever that is. The issue is I can't have a negative base. I can't. So what I'm going to do is I'm only going to care about the positive part. X equals the positive 16th root of 2. So stupid typo by me. Probably the first of many. All right. Now we have 2 logs of the same base added to each other, which means I know I can just multiply the insides. Log base 4 of 3x equals 2. I could take that, rewrite that as that, or I could just take 4 to the of both sides. So I'm going to do 4 to the of both sides. That crosses out. That gets me 3x alone equals 4 squared, which is 16. Divide both sides by 3, divide both sides by 3, and x equals whatever 16 over 3 is. 5 1/3, 5.3 repeating. Okay. Rewrite e to the x as a e to the second equals x as a logarithm. All right, so if log base e of x is the same as ln, and I have ln of x equals y, I can rewrite that out as log base e to the y equals x. So e to the y equals x can be written out as ln of x equals 2. Solve ln of x squared equals 4. Again, I can do the whole e to the of both sides, which I will do, and the same rules apply. Or if I take e to the ln of x squared, I get x squared. So let me write that out here. That's going to equal e to the fourth. Now, this is what I was hoping would happen in part C of the previous problem when I created it, but I just had to mistype. I just went with it anyway. In order to get x all by itself, you square root. And whenever you square root both sides, you have to attach a positive or negative. So x squared is going to equal positive or negative e squared. Regular x, not x squared. Regular x. I don't know why I did that. Regular x. Now you might be thinking, this is bad, sir. This is bad news because of the way you said you're not allowed to have negative. If I were to take this guy and plug it in and plug in e squared, that's fine. If I were to plug in negative e squared, I'd still get positive. And you're not allowed to have negative ln's, but this would still work. However, if I gave you the problem as this, okay, I cannot have a negative in here. But since I gave you the problem as that, I'm allowed to plug it in. So keep in mind, what you really want to do with some of these is if you get negative answers, plug them into the original problem and see if it would still work. In this case, it would still work. If I gave you this guy can be written as that. However, I'm not allowed to plug in a negative into x. It wouldn't work. So, but since I gave you the problem to start out like that, it still works. So I know tricky, very tricky, but that's logs for you. Solve for x in the equation ln of 2x plus 3 equals 4 and express the solution in exponential form. Okay, why don't I just take e to the of both sides again? That way these guys cross out. I get 2x plus 3 equals e to the fourth. Subtract 3, cross you out. 2x equals e to the fourth minus 3. Divide everything by 2, and x is going to equal e to the fourth minus 3 over 2. No calculator. No calculator needed. So being this problem and seeing the last slide, not fun at all, but we got through it. And what's important to realize is you have to plug stuff in at the end to make sure it works. And if I plugged in negative e squared to that guy, you would have negative e squared in parentheses squared, which makes it all positive anyway, so it's okay. But again, if I gave you this problem, if I made it look like this first and I tried to plug in negative e squared, it wouldn't work. So it all has to do with the original problem, whatever it is that you're given. Oh, sorry, Mr. Graph. Let me move my face. Graph f of x equals 2 to the x. So I'm going to make myself an xy table. All right. I already know that this is going to look something like this, but I want to be sure. I'll choose negative 1, 0, 1, 2, 3. If I plug in negative 1, that's 2 to the negative 1, which is a half. If I were to plug in 0, I get 1. If I were to plug in 1, I get 2. If I were to plug in 2, I get 2 squared, which is 4. And if I were to plug in 3, I get 2 to the third, which is 8. Okay? So let's make sure that I go out this far. I have a feeling that I'm supposed to do a log. Oh, yeah. All right, so negative 1 was a half. Boom. 0 was 1. Boom. 1 was 2. Boom. 2 was 4, right? Boom. And then 3 was 8 somewhere up here. And then we get that nice exponential. It's flat right here and then starts to curve up and really curl up. Okay? Determine the domain and range of f of x. Well, the domain is everything. The domain is going to be everything because I'm allowed to plug in whatever I want into an exponential function, whatever I want. Okay. The range is only the x values. So I'm going to say 0, not a bracket, to infinity. Okay. As you can see, this will never go below the x-axis. This will always flatten out. And that makes sense. No matter what negative number, if I were to plug in negative infinity, it would be 1 over 2 to the infinity, which is basically 0, but not quite 0. Remember limits? So that's why that doesn't work. Now, find the inverse of f. So that's fine. I will call u y just so I can swap it out. So I have 2 to the x. Step number 1 is you swap your x and your y. So I have 2 to the y now. In order to find or get y all by itself, I have to log base 2 both sides. So that gives me log base 2 of x is going to equal y. Or you could just rewrite it in exponential form, whatever works. Let's flip this over. Y equals log base 2 of x. And let's call it f inverse instead of y. So f inverse is going to be log base 2 of x. Now I know what's going to happen because of what I did a couple slides ago. But I'm just going to make sure that I do it right. Now, I have this guy. I have it right there. Okay, this is the same as that flipped. All right, so what I'm going to do is my x and my y values are going to flip-flop as well. So you become 1/2 -1. You become 1, 0. You become 2, 1. You become 4, 2. And you become 8, 3. So 1/2 is -1. Boop. And 1 is 0. Boop. And 2 is 1. 2 is 1. Boop. And 4 is 2. Boop. And 8 is 3. 1, 2, 3, 4, 5, 6, 7, 8 is 3. And then that curls up. And then what you could see is that this, is a mirror image over the axis y equals x. Okay? So, yeah, kind of nice how everything just works out, isn't it? Kind of nice. Moving along, and we're moving. Oh. Didn't I just do this? I did. Okay. Graph the function y equals log base 2 of x and determine its domain. So what I'm going to do is I'm going to write this out in its exponential form so I can graph it. All right. So 2 to the y equals x. So what I'm going to do is I'm going to plug in a bunch of y values like -1, 0, 1, 2, 3, and that'll give me some x values. So if I plug in -1, I get 2 to the -1, which is 1/2, so x equals 1/2. If I plug in 0, I get 2 to the 0, which is 1. If I plug in 1, I get 2 to the first, which is 2. If I plug in 2, I get 2 squared, which is 4. And if I plug in 3, I get 2 to the 8th, 2 to the 3, which is 8. And so, so you get this guy again. So I'm not sure why I decided that I'd do it. Again, wasn't really thinking, I guess, when I made these. That's all right. More time is more money in YouTube land. Solve the equation log base 3 of 2x plus 1 equals 2. Is this a calculator section? No. So I am going to take 3 to the of both sides. That cancels out and gives me 2x plus 1 equals 3 squared, which is 9. Okay. -1 minus 1. That gets me 2x equals 8. divide by 2, cross u out, x equals 4. Am I allowed to plug in 4 into the original problem? Yes, because then I'll take the log of a positive number. It all works out. It all works out. Graph the function from part A and the solution from part B on the same set of axes, identifying the points of intersection. All right, so if I were to do that, I guess it wants x equals 4. So you would get something that looks like this. And so the point of intersection would be log base 2 of 4. And if I wanted to find out what y was, I could rewrite this as 2 to the y equals 4. I can rewrite 4 as 2 squared. Y is 2. Look at that. Interesting. Interesting. I'm glad I made that problem up. Actually, I used ChatGPT for help on that one. Thank you, ChatGPT. Thank you, AI. Allen Iverson. One of my favorite athletes of all time. Still no calculator. Oh, my gosh. All these problems without a calculator. Simplify the following expression. 2 log base 5x log base 5 3y minus log base 5 of z. First thing I have to do is deal with the exponent stuff. So now I have log base 5 of x squared plus log base 5 of 3y minus log base 5 of z. These two fellas are being added, so I'm going to multiply the insides. Log base 5 of 3x squared y minus log base 5 of z. Well, that, by golly, is subtracting, so I'm going to divide the insides. So just so I have plenty of space here, I'm going to end up with log base 5 of 3x squared y over z. Expand. Okay. What I did to do this one is I did exponents first, then I added, then I subtracted. Okay. I'm going to go in reverse. I'm going to do the stuff that would subtract first, and then the stuff that would add, and then the stuff that would exponent. So let's split this up using the division part first. So ln, remember ln and log follow the same rules. So ln 3x squared y cubed minus ln of z squared. Now I'm multiplying 1, 2, 3 things inside that parentheses, which means in order for me to get to that point, I must have added those 3 things to begin with. So you become ln of 3 plus ln of x squared plus ln of y cubed. Over here, I still have minus ln of z squared. You're fine. These guys have exponents, so let's 1, 2, 3, bring them out. 2 plus 2 ln of x plus 3 ln of y minus 2 ln of z. Okay, let f of x equals log base 4 of x. I can handle that. Find g of x, which is f of 4 plus 2f of w, so some random w, minus 8. Okay. F of 4 means, let's go off to the side. F of 4 has me plugging in 4 to that original guy, so log base 4 of 4, fun fact, is equal to 1. So f of 4 is 1. So you're now 1. So g of x is going to be 1 plus 2 f of w, which is going to be log base 4 of w. All right. Minus 8. Which simplifies out to, let's put this up here, log base 4 of w squared minus 7. Let's wrap that into parentheses so I know that you're not a part of log base 4. What a weird problem I made up. Okay. Still no calculator. My goodness. My goodness. Given the function f of x equals 3e to the 2x minus 1, find the inverse function. Okay, so let's do this. Let's make this y equals 3e to the 2x minus 1. I have to swap x and y's, so x equals 3e to the ln, no, to the 2y minus 1. I have to divide both sides by 3. So x over 3 equals regular e with a space on purpose to y minus 1. ln both sides. It's supposed to be a parentheses. Things are a little laggy today. ln of that cancels that out. So now I have ln of x over 3 equals 2y minus 1. So let's add 1. ln of x over 3 plus 1 equals 2y. Divide both sides by 2. And that could be written out as 1/2 ln to the of x over 3 plus 1/2 equals y. Now, why did I do that? Why didn't I leave that as over 2? Well, because that over 2 implies that ln has a coefficient, which means I'm going to make you an exponent. Now, an exponent of 1/2, well, that is a square root. So now you become ln of the square root of x over 3, right, plus 1/2 equals y. Or I'll just call it f inverse of x. That's awful. That's just plain awful. Determine the domain and the range of the original function. Well, what am I allowed to plug in? Again, I'm allowed to plug in any number I want as long as it's not negative. So that's not going to change anytime soon. I mean, of course, that would also make sense. I can't plug in a negative inside of square root 2. So my domain is not going to change. Okay, so I have a domain of negative infinity to positive infinity. And my range is going to be, I'm adding a half. So since my range is a half, I'm going to bump it up one just a little bit. Okay, so this is a ln. So my range is going to be 1/2. Oh no, this is an ln function, which means it looks like this. So I have to take it back. I take it back. I take it back. I even said this earlier. Here. Determine the domain and the range of the original function. Well, here's the original function, which is exponential. Okay, exponential. So what I have is, since it's exponential, it's squeezed a little bit. That's what that 3 means. That 2x minus 1 shifts it right a half. Yes, shifts it right a half, which is not going to change much. It's still going to give me a domain. It's still going to give me an image that looks like this. Maybe I should have moved it over, but we get the idea. The domain of this guy, the original function, is I get to plug in whatever I want. You can't stop me. The range is I'm still going to flatten out at 0 and go all the way to infinity. So, because I'm not adding or doing anything on the outside. So my range is going to be 0, flattening out, and infinity. Now, this guy is having me find the domain and range of that guy. Well, aren't they just flip-flopped? Because aren't I going to get something that looks like this, give or take, which means the domain is I'm not allowed to have any negatives. Okay, when I have an ln, I'm not allowed to plug in any negatives. And look at that, I have a square root, so I'm definitely not allowed to plug in negatives. And my range is going to be, as many as I want. Sketch a graph of each, donezo. That's supposed to be a check mark, but since things are laggy a little bit today, since my little Chromebook is lagging, it doesn't look as good. Oh man, will this affect how many views I get? No. If you made it this far, you're committed. You're committed to the bit. Thank you, Lord Jesus. There's the calculator. So let's just jump right into it. In order to solve this, I need to make sure that I have it in a format that makes it graphable into a calculator or something like that. I can't just plug in X values and see what happens. So what I'm going to do is I'm going to rewrite this in log form. Log base 10 of 56 equals X. Log base 10 is the log in your calculator. So I'm going to step to the side and let your calculator do all the work. Okay, now that we've got this in log formation, remember log base 10 and log are just the same exact guy. So all we have to do for this guy is log 56, and then round to the 3 decimal places, 1.748, and we're done. So Mr. Calculator says that X is going to equal 1.948. Cute. Thank you, Mr. Calculator. Okay. Let's rewrite that as a log because, again, I really don't want to plug in a bunch of X values and see which guy matches up. So if I write this as a log, I have log base 3 of 143 equals 4X. Okay, again, take log base 3 of both sides. That'll get you that. You'll be all right. Now, I can't plug that in my calculator, but you know what I could use? The change of base formula. So what I'm going to do is the change of base formula says log base b of stuff is the same thing as log of stuff over log of base. So what I'm going to do is I'm going to plug that guy into my calculator and see what my calculator gives me. Then I'm going to divide it by 4, and I'll get my answer. All right, so now we're at the part of the problem where we could just use the change of base formula. So we could do log of 143, close that parentheses, divided by log of regular 3. If I could just hit the button, there you go. Now that's going to get us a terrible number. All right, so without having to go back and forth and back and forth and back and forth, what we'll do after that is, since the next step would be divide both sides by 4, let's just do that right now. Divide both sides by 4, and you've got 1.129 rounded to 3 decimal places, so that's going to be our answer, 1.129. All right. So again, I plugged that person into my calculator, got some gross number, divided it by 4, and when I divided everything by 4, x equals 1.129. Okay. Let's do some combinations. Let's move that guy up there first. So I have log base 10, that's nice, 7x plus log base 10 x squared equals 1. Since I'm adding 2 log base 10s, I can combine those through multiplication. So multiply the inside. 7x times x squared is 7x cubed. So log base 10 of 7x cubed is going to equal 1. Since that's log base 10, I can 10 to the both sides. That crosses out. And now I have 7x to the third equals 10 to the first, which is 10. I'm going to divide both sides by 7. And now it's a matter of cube rooting whatever 10 over 7 is. I don't know what the cube root of 10 over 7 is. Go ahead, find out. All right, so for this guy, really the only calculator part that we need to do was take the cube root of 10/7, which, we should all know, but for some reason, I'm just going to show it to you anyway. So there's the cube root. You hit math 4, and 10 divided by 7, all in the same root, and you get 1.126, very similar to the answer that we had before, but has nothing to do with each other, 1.126. X equals 1.126, baby. Whew. Very similar looking answers. Very similar, close to each other. You know what? My lights just went out, but I like it. It's dark. It's creepy. So I'm going to keep it that way. Solve each. Okay. I have 2e to the x, so why don't I just rewrite that as e to the 2x, because I can multiply that to there. E to the 2x equals 7. If I wrote that out in log form, or take the ln of both sides, I would get 2x equals ln of 7. So what I'm going to do is I'm going to run to my calculator and find out what ln of 7 is, and then divide it by 2. Okay, so the way I handled this one is I just divided both sides by 2 right off the bat. So now all I have to do is ln of 7 over 2. Ln degeneris is 7 over 2. And I get 1 point, a lot of 1 point stuffs in this packet, but that's what I get when I create my own problems. 1.253, let's round that puppy up. All right, x equals 1.253 for that one. All right, I moved my desk because no more leaf blowers. All right, B. Let's combine these guys right here. Subtracting ln's means you divide the inside. So ln of 4x divided by 2 is just 2x. That equals ln of -1. Ln's on both sides, So let's e to the both sides. E to the. That cancels out and leaves me with 2x equals -1. I don't think I need a calculator for this guy. Divide both sides by 2. X equals -1 over 2. I did it, and I did it right. No. Whenever you see a negative answer for a ln problem, check your work. Because if you were to take -1/2 and plug it into x here, you would get ln of -2. And what's ln of a negative number? Impossible. And you should have seen that right off the bat, boys and girls. You can't do this. This one is a no solution. Can't do it. There's no answer. Sorry. There's no answer for that guy. So no calculator needed because it's impossible. Let's take a look at C. Nothing's impossible with this one. This one seems pretty straightforward. First thing I want to do, though, is move that exponent up there. So now I have ln of 6x plus 5 equals ln of 1 to the 4th power, which is just 1. Wait a minute. Ln of 1? Log of 1? That's just 0. Oh, yay. So you could turn that into that. Even if you didn't realize that and you tried to combine with the ln of 6x, you'd still be all right. But now I have this. I'm going to subtract 5 from both sides, and I get ln of 6x equals negative 5. Okay, ln, I'm going to take the e to the of both sides. E to the of both sides. That crosses out and leaves me with 6x equals e to the negative 5th. So in my calculator, I'm going to do 2 steps. I'm going to find out what e to the negative 5th is, divide both sides by 6. That'll get me my guy. Okay, so we made it this far. Let's do e to the negative 5th first. So where's e? Second ln gives us e to the. So now all I have to do is type out negative 5th, hit enter on that guy. Logically, the next step would be divide both sides by 6. So let's do that. And we get an awfully small number. 0.001 is going to be our guy. So x equals 0.001. A really small number, which makes sense because e to the negative 5th is the same thing as 1 over e to the 5th. Really small number. Divide that by 6, much smaller number. So there you have it. Fun, 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 fun. Be careful with B. B is very easy to screw up. So just don't screw it up, all right? Okay? Don't screw it up. Last slide. PERT. Find the value of an account with a principal amount of $10,000 compounded continuously at a rate of 0.3% for 10 years. So this is the continuously compounded interest formula. I'm going to plug into my calculator 10,000, because that's my principal, times e to the. Now, it's very important when you use r, you're using r as a decimal. So 0.3% is 0.003. And I'm going to multiply that to 10 for 10 years. Wow, 10 years. I bet you I'm going to make so much money after 10 years. I guess we'll find out. Okay, we got ourselves a PERT problem, so get your shampoos ready. All we have to do is just type stuff in. 10000. That's 10,000, right? It sure is. E to the is this guy right here, second ln. And remember, when you're using your rate, you have to use the decimal form. So 0.3 is 0.003 times 10, because that's how many years that we have. And now it's just a calculator exercise. And so after all that time, we gained $300. Good job. Banks are a ripoff. You just use your money and put it in gold. By the way, 0.545 rounds up to 55 cents because we're dealing with money, baby. And you're wrong. You made like $300 after 10 years. What a waste. So this becomes $10,304.55. Remember, it's money, so round appropriately. Using that information, how long would it take for the amount of money to double? Well, let's set up this similar equation here. If the amount of money doubles, then I'm going to have 20,000 equals 10,000 e to the RT. What was R? 0.003 t. Divide both sides by 10,000. Divide both sides by 10,000. And you become a nice 2. So 2 equals e to the 0.003t. Let's ln both sides. For when I do, it makes the e go away. So if we ln both sides, that leaves me with ln of 2 equals 0.003 t. So what I'm going to do is I'm going to run to my calculator, find out what ln of 2 is, then divide that by 0.003, and then I'll get t. All right, so we're going to do 2 steps in 1 because of the math. After we ln'd both sides, we have ln of 2, so that's the first thing that I'm going to do, hit enter. That gives me that gross-looking number right there. Now, in order to get t all by itself, we divide both sides by 0.003. So I'm going to do that, divide by 0.003, and it's going to take us not long at all. 231 years to double our $10,000 at that rate. Again, banks are a ripoff. Just buy Pogs or Beanie Babies. Remember that trend? People thought if you bought a bunch of Beanie Babies, it would be worth something later in life. Didn't work. It's going to take you 231 years and a few cents in order for you to double your investment gross. All right, didn't take us long at all. Just, $231 and a little extra. Years and a little extra. So, you'll die like 15 times and you'll be able to double your investment. Oh, banks, you get us every single time. Curse you. Don't tread on me. Just kidding. Don't put any negative comments in the comments for saying that. Okay, please. Or do. It doesn't really matter either way. I get money. All right, that's that. One more, then we'll wrap up Unit 2 of AP Precalculus. So pretty exciting stuff. Thanks for watching as always. Love you so very much. Bye. Hey, hey, hey.